to once again. In this instance, in equation, you're going to use mathematical induction to prove that 7 to the power of n plus 2 plus 8 to the power of n plus 1 is divisible by 57 for every non-negative integer n. By this, we mean there are no negatives. So, if this expression that carries an n plus 2 and a 2n plus 1, if this n over here is substituted by a number that is not a negative number, this whole expression should be divisible by 57. As you can see, yaka award was 7 marks, which means panibasa. So tagu jamba right into it. So up and down this expression, 7 to the power of n plus 2 plus 8 to the power of 2n plus 1. This is for clarity purposes. Now I'll break down this solution into 3 stages. Our first stage is going to be called the base case. And this is our first stage. So in this base case, we are going to assume that this n over here is equal to a non-negative number, which is 0. For 0 is not a positive or a negative. So what are we going to do? We are going to substitute this n with a 0. So to yapanapa, we rewrite the expression for clarity purposes, so that everything can become clearer. 2n plus 1. Now if we substitute this equation with 7, notice 7 to the power of 0 plus 2, and then plus 8 to the power of 2 multiplied by 0 plus 1. Here 0 plus 2, that's 2, plus 8 to the power of 2 multiplied by 0, that's 0 plus 1, that's 1. You could use equal signs again for clarity purposes. Okay, so next we equate, actually we evaluate. So 7 to the power of 2, that's 7 by 7, giving us 49. 8 to the power of 1 is the same as 8 times 1, which gives us 8. 49 plus 8 gives us 57. Now, if we divide this expression, which is this expression, by 57, it is true that the expression is going to be divided by 57 for every non-negative integer. Saka, for this base case, we have indeed proven that it's true. So now we're moving to the next step. So this is the next step. It's called the inductive hypothesis. Since we are proving this equation using the induction, mathematical induction, our next step from the base case is going to be the inductive hypothesis. At this stage, we're going to assume that this n over here, the same one that we assumed that it was 0. At this instance, we want to assume that it is a number which is equals to k. By saying it is equals to k, we are saying atiziwe kuti I number ichi, what is the value of this number in this range of non-negative integers. So we are just assuming that at least there is a number called k, maybe in the 5, but we don't know in the 5. We are assuming that 5 is equals to k. So this n is going to be to that assumed number k. So we are also going to change this equation to support this value ya k. So we are going to substitute all the n's in the equation with k. So tichaya kuno kutotiji 7 to the power of k plus 2 plus 8 to the power of 2 multiplied by k plus 1. We simplify, by the 7 to the power of k plus 2 plus 8 to the power of 2k plus 1. So after doing this, we are done with our inductive hypothesis. So we have to keep this expression in mind, knowing that we assumed that this expression is divisible by 57. For the sake of clarity again, I'll just write is divisible by 57. Okay, so what do we do next? We move on to the inductive step. Okay, now we are moving on to the inductive step. At this step, we are assuming that n, instead of being k, we are assuming that n is equals to k plus 1. By k plus 1, I mean that it is going to be the next number from this k. So the next number from k obviously is k yache plus 1. saka ndo zvatiri kutaura apo kuti n wedu number yedu is equals to k plus 1. The next number from this number inenge ichinzi k plus 1. So we're going to substitute this k plus 1 into this equation tichibvisa n tichisa k plus 1 pana n person. So we are now coming to this expression as well, and we're going to say, for the sake of clarity again, I'll use brackets and say k plus 1 since I'm substituting n. Tichibvisa n tichisa k plus 1 plus 2. This will also make our equation clearer and easier to work with, as you could confuse it if you use my brackets. So again, we open brackets and put k plus 1 plus 1. So we'll get rid of the brackets, and then we'll say k plus 1 plus 2 plus 8 to the power of 2k plus 2 plus 1. Now we have a value for this inductive step. Now we are saying that this value indeed it is divisible by 57. Now these are the assumptions that we have made in all these three steps. The first step was assuming that n is equal to 0, the second step was assuming that n is equal to k, and the next step was assuming that n is equal to k plus 1. And now we want to evaluate for this equation to make sure that it is divisible by 57 and hence answer this question that we have here. Okay, so now we are going to make sure that this equation proves to be true, that it can be indeed divided by 57. So what are we going to do here? We are going to introduce the law of indices. So this expression 7 to the power of k plus 1 plus 2, it means that we are saying 7 to the power of k multiplied by 7 to the power of 1 multiplied by 7 to the power of 2. So I want to remove this 7 to the power of 1 in the middle and leave k plus 2 as one expression. So this is what I do. I come over here, then I say 7 to the power of k plus 2 plus 1 is becoming an individual and independent number, and this is what we do. And then we introduce our addition sign, and then we move on to the next to the side, and then again I want to separate this plus 2 of here, so I'll use the same law, 8 to the power of 2k plus 1, and then I'm going to multiply this 8 to the power of 2. Now we have clearly introduced the laws of indices, and now I want to solve for this number so that I can easily erase it and get rid of it. Now we're going to move on to this next step, where we are going to, over this side we're going just to repeat the same, but then after here obviously this again comes, but now we're solving for this number over here. That's 8 to the power of 2. That's 8 times 2 giving us 64. So now I want to make sure that I have a number that gives me 64, but it has to be from two numbers. So I want to add 57 plus 7 to give me 64. Okay, so I'll come here and rewrite 8 to the power 7 to the power of k plus 2 multiplied by 7 to the power of 1 plus 8 to the power of 2k plus 1 multiplied by, instead of 64, now I'm going to write this expression 57 plus 7. Now why did I use this expression? Because I want to leave 57 over here, since we said that our expression must be divisible by 57. So here I want to leave a 57 over this side, and since I have 7s on the other side, I want to make sure that I can move this 7 over here to this side and make it a subject of the formula. So that's what I'm going to do right now. So I'm going to multiply this 8 over here, 8 to the power of 2k plus 1, with this expression here. So what do? I rewrite the expression as well. I hope you are following through, because part 3 is the last part where we get to prove that our equation is divisible by 57. So we are multiplying 57 multiplied by 8 to the power of 2k plus 1, yeah, to some brackets, and then plus this plus over here, and then we also multiply 7 with this same expression, 8 to the power of 2k plus 1. And then what do we do next? We move this 7 over here by making okay, yeah, let's just move it first, and then we'll 7 to the power of k plus 2 multiplied by 7 to the power of 1 plus this 7 over here, 7 multiplied by 8 to the power of 2k plus 1 plus 57 multiplied by 8 to the power of 2k plus 1. You might ask yourself questions, why am I bringing in brackets at this moment? Using brackets and these dots is the same thing. So this also means multiplication, and this bracket also means multiplication. So now I'm going to make this 7 the subject of the formula over this side. I'm making this 7 the subject of the formula. So I'm saying 7, and then I'm going to open brackets. Now here, I'll take this 7 over here and make it the subject of the formula. So that means we are remaining with this 7 to the power of k plus 2 plus the plus sign over here. Then I'm going to take this 7 and make it the subject of the formula. So that means we're going to remain with 8 to the power of 2k plus 1 plus 57 multiplied by 8 to the power of 2k plus 1. If you can see and take a close look at this expression, we have this expression here, so okay, it is repeated again. This was from the second step. The second step where we said n is equals to k. We also assume that it is divisible by 57, and that was 7 to the power of k plus 2 plus 8 to the power of 2k plus 1. So since we have the same expression over here, 7 to the power of k plus 2 plus 8 to the power of 2k plus 1, it means that this expression over here is divisible by 57, and this expression over here is also divisible by 57. Hence, we can go forth and make a judgment, and the judgment would be like this. The whole expression proves to satisfy the notion that it is divisible by 57, and this is the end of our working out session. I'd like to call it so. Yeah, so this is the answer, this is the solution, this is all that we needed to do. And this expression over here, actually this statement over here is necessary. You have to write it down, and that's how best you can answer this question. So thank you for your time, and please make sure that you subscribe to the channel, STR8EDU Tutorials, because those support them not cheaper as fellow Zimbabweans. Let us support one another's business. And I thank you for your time as well.